related to the project of this course? Everything is on track? You know, you get the idea what I am expecting, so either, you know, even if you don't have now any question, please send me an email if you have any question. If you have any question about the content, I don't know, please forward me a table of contents, I mean a tentative table of contents to see whether the things that you are planning to do is okay. So I'm there to help you. Don't hesitate to send me an email if needed. But otherwise, I suppose that everything is okay, and then I will not worry about. Okay? Yes.
Just at a high level, when we are looking at the advantages and disadvantages of our tool technology or of our tool in the technology, should we be running a similar benchmark against a traditional technology as well to show how they differ?
Yes, the idea, as I mentioned to some of you that came to my office to discuss the project, is this, I don't know, I'm in the business of data management since at least 88. So a long time ago, so I have seen many technologies that were very hype at that moment, and today totally abandoned. So and even myself, I was investing in those technology time and effort. I was thinking that it was a promising technology, and then the problem is that even the nicest technologies from the technical or technological perspective do not survive. For which reason? Why an amazing technology on which I bet yes, okay. An amazing technology on which I invested, I believe very much, disappeared a few years later. Why?
Lack of community support.
Yes, and other reasons.
Requirements change, like
Requirements change, yes. Other reasons, all these you're saying is valid, but the striking value, the striking reason was something else, and basically was money. As always in all this world, why money came into the equation?
Everyone already has relational databases, so it costs a lot to
That is indeed. Thank you for this answer. This is the right question. For some reasons, in the 1990s, there was a huge hype of object-oriented databases, and you know that object-oriented is the principal or main paradigm for software development, whether it is C# or Python or whatever. And do we have object-oriented databases nowadays? You will see some of them, but these are not mainstream. Why?
I have a question. By object databases, you mean NoSQL databases like MongoDB?
No, object-oriented database in which you define a class person, and then a class student, and a class professor, and then the database model and language understand this hierarchy with polymorphism, with all the traditional things of object orientation. You know object orientation in programming, okay? And so why it is not the case that if everybody is doing object orientation in programming, why do we need to disassemble a full car into different tables to put it into the database, and then when you wake up in the morning and open the database, you need to reassemble the same pieces here and there in different tables, assemble, you have a car for driving in the morning. This is more or less the same idea what happened when you disassemble an object to say in a database, in a relational database, and then you need to reassemble when you switch on the database. Why? Please, Andres.
At least from what I've seen from work, like most visualization tools, like machine learning tools and all that, are, most of the support goes to relational databases. Maybe I don't know, it's a term, since they've been like working with this paradigm so long, I believe maybe it's that it has matured enough to get to the point like this is like the most efficient way of doing some things.
Yes, you are right, but this does not, yes, somehow this is money, but I can tell you the story in short. These database technologies, object-oriented databases, were very hype in the 1990s, and then what happened? They were losing Microsoft, Oracle, and etc. were losing market share. Because of course it is much more easy if you have a C++, a C++, or C# or a Java object, and then have an immediate matching between the database, the model of the database, and the model of the program would be the same. So no impedance mismatch. This is a technical term for transforming one model into another. And then there are two issues. Then how these huge companies reacted to this hype. Therefore, the Oracle invented an amazing marketing thing, but it is a disaster technologically. Is object relational model in Oracle. Then, when the people asked the Oracle representative, should I switch from Oracle? I having already Oracle in my company. Should I switch to object-oriented databases that this is promising very much? No, don't forget. We also provide object relational model. Go deep into the model is a disaster. But from a marketing perspective, they convinced all the people that to not switch to that technology. Other reaction from other companies was that I have enough money, I bought the company which is competing with myself. At that time it was a French spin-off from a research center organization in France, which is what's called O2 for object-oriented. So basically, it was bought by some other huge database market and destroyed. So basically, the idea is as follows: even if the technology is the best and will facilitate the life of everyone in the planet, it does not necessarily mean that it will survive. So going back to my idea of the project, I have seen many of those. I have working on deductive database and I made many amazing things in deductive databases. Some of you already asked me to work on the deductive database topic. I discourage because nowadays nobody is using the deductive databases, and therefore, yes, you can invest and discover some things. You are going to use that into work in the future? Never. Forget about that. So why waste your time in this in learning this technology that is not useful anymore? I mean, it's an amazing technology. I spent, I don't know, 5 if not 10 years of my research doing deductive database. It is completely, all my papers are on that topic are completely forgotten. So be pragmatic. Going back to the project and your question, Adam, I have already my database technology relational, whether PostgreSQL, SQL Server here at the university, Oracle in many banks. And then if you go to your chief technology office and then say, I would like to use Firebird or MongoDB or whatever, my new technology, my new tool in this database, you need to prove to the CTO that this application will be much faster. You need to, when you are working in company, you need to, for every new project, you need to assess the return of investment. Yes, this return of this if we launch this project, that will cost us that amount of money. But nevertheless, in 6 months, in 1 year, we will have this return of investment. Then we can balance. And then you need to prove to this chief technology office that you cannot obtain this return of investment with the relational database, Oracle or SQL Server that you have already in place in your company. So the idea is very pragmatic. Please compare your new technology with a traditional technology, and if you say at the end of your project, no, it's a disaster, MongoDB does not is useless with respect to PostgreSQL when, and this is completely true, is useless with respect to PostgreSQL when manipulating JSON databases, it's a perfect result. A negative result is a perfect result. You invested in your company 1 month of your time, but you make them gain millions because they do not launch a project on that technology. Okay, for this idea of the project, be very pragmatic. I will be your chief technology officer, knowing very well relational databases, and when you present your project, I will play the bad guy role and say, no, prove me that I need to switch to this technology. So this is the idea. So now let's go to SQL Server and the triggers. Let me try to switch this thing, and the cable should be somewhere here. Yes, thank you. I was looking for that. Video. What about this? If someone is there that wants to share the table with here, there is no problem, okay? So you have already used enough in the last session. You have used enough SQL Server triggers. Let's see a little bit. I'm not asking to you understand the nitty-gritty details about that, but just understand what is the difference between the different implementations of triggers. Let's see about Oracle. Oracle has 2 granularities. You remember what we discussed in the last week. Tuple level granularity versus statement level granularity. Can someone explain me or recall to the people that were not there the idea?
So the idea with tuple level granularity is that you implement the checks on each row, and statement level you perform the actions described by the statements, and in the end you just check the resulting state of the database.
Many thanks for that. Exactly like this, but maybe I would add a little example so you can understand. Suppose that you have a table and employee table, and then you have a salary here, a salary column, and the SQL statement update salary, update employee, set salary equal salary times a coefficient 1.3 to increase the salary 3% of the employee. So if you have a trigger associated to an update to this table, depending on the granularity that we have, or the granularity of the trigger, we have 2 possibilities. We do all the updates and increase 3% of the salary of all employees. Once this is done, we launch all the triggers that should be reacting after an update of the salary of the employee table, okay? This is the statement granularity. We execute fully this statement, and then we launch once the trigger, okay? The other one is the tuple level granularity. I would definitely disallow you. Do not suggest to use this level, this tuple level granularity, because it's a disaster on the long term. So basically, you update this tuple, you increase the 3% of the salary, and then launch once the the trigger or all the triggers or all the chain of triggers that will react to this single update, and then when all the chain of triggers stop, then you go to the next tuple, update 3% in addition, and then continue again, launch all these triggers. As you can imagine, from performance-wise, this is not ideal. As you will see, we discussed that already last time, that in order to this to work, you need to have the inserted and deleted table that you have been using for SQL Server. This does not exist in Oracle, so therefore it is impossible. And then when you ask, for example, in order to have this, suppose that this employee is managed by this employee. You start with this employee, and then you have the traditional constraint that you have already implemented in SQL Server, that an employee cannot have a salary bigger than his manager. You remember this constraint? So at the beginning, you suppose that the table satisfies the constraint. When you modify the first employee, it may be the case that by multiplying by this factor, it will be bigger than his manager. But at the end, you understand this, that by definition, if the table satisfies the constraint at the beginning, when all this update will be executed, again, the table will satisfy the full constraint. Okay, with that, in the meantime, it could be the case that the constraint is inconsistent. But this is a temporary state before reaching the final state. Do you agree with that analysis? Therefore, it's impossible to analyze this constraint in a statement by statement and a row by row level, okay, for that, because you have an update that affects all the rows of the table. Therefore, this kind of, in order to ensure this constraint, it should be like this. The problem is that in Oracle, you don't have the update table. When you are asking the insert and delete table, temporary table, when you have here, the trigger will ask, what is the salary of the manager? The salary of the manager is in a table that is mutating. And then if you go to Oracle, if you look on the web, mutating table Oracle, you will see thousands of web pages trying to solve this mutating table error in Oracle. Why? Because you cannot access a table that is currently being updated. Therefore, because during this update, this table is locked. Then when you are asking, what is, I'm having 3% for the first employee. I need to look for his manager. His manager is in a mutating table, and Oracle says, no, this table is not accessible. So, because there is no updated or delete table, what do you need to do in order to solve among all the multiple issues that are, multiple solutions that are there for Oracle? You need to copy this into a temporary table. So you do yourself by hand the update and deleted table. You copy this table in a local workplace for you. Instead of asking in your trigger whether the salary of this manager in this table, you need to ask in your local copy. Then this table is yours. You can do whatever you want and verify all these things like this. You understand the idea? The problem is that tuple level triggers is a nice idea, but it completely breaks out when a little bit more complexity is, as soon as we are not talking about very simple things, tuple level granularity is a disaster. So I do not recommend this kind of thing, but you don't have much choice in Oracle. Then another difference with respect to, no, this is the same as in SQL Server. Can someone explain what does it mean immediate execution mode? Yes?
The execution will occur as soon as the event is triggered.
perfectly right, but Charlotte will not understand the intuition behind that. So let me allow to put an example. We have a begin transaction here. We have many things that going on a transaction. We have an insert here. We have an update here. We have a delete here. End of transaction. Immediate versus deferred execution mode means that this trigger will, this statement will launch several triggers. This one also. This one also. The preferred model that is not even implemented into SQL Server is that sometime, as I mentioned, during this process, intermediate process, the database, while updating this table, the database is in an inconsistent state. It will be correct at the end of the state, end of the modification. The idea is here, suppose that you are registered to the university, you need to register to define the faculty, and then you will basically have a new student into this faculty, then you have to update whatever, you have to update your choice. You are not looking anymore in the Master of Computer Science, we are looking on the changing from computer science to cybersecurity, concrete example at ULB. And then you, when you are accepted at the Master of Cybersecurity, you delete your registration for the Computer Science Master. So this is an operation that should be done in one single step. Otherwise, between this, when you added your choice to your registration to the cybersecurity master, there is one more student in the register to the ULB than necessary. By removing this, the old registration, you have the correct number of students at the ULB. You understand the idea? So in the middle of this statement, of this in the middle of this, peut-être que tu dois chercher une chaise si tu veux bien, Samy. In the middle of this transaction, the database is in an inconsistent state. Therefore, what is important is that we are able to do deferred statement, deferred trigger execution. Now, when the operation is ready, we can count the number of students in faculty and then do all the check constraints. Okay. Neither, at least myself, I never was able to find how to do that in SQL Server. Maybe there is in the new version, there is a way to do it, I don't know. Or maybe if you find, please let me know. In any case, what is there in both SQL Server and Oracle and many other is immediate execution state, meaning that when you arrive here at the insert, either you do is immediately before or immediately after. Question?
Concept of batches is something different?
Batches.
Batches, yes. You can send commands in batches.
A batch command is they have an implicit begin transaction and transaction.
That's it.
That's it. So again, if we have two granularities and two before and after, we have 4 possibilities. This is an example of a statement level, row level for each row. Can someone explain me in English, plain English, what does this trigger is doing?
I can explain everything except for that reference line.
Yes, perfect.
So you are creating a trigger called no non-descending salary, I guess. After there is an update of the salary on a row called employee, you create some sort of a reference that's going to compare to, I guess, tables T1 and T2. You go through each row, and then as you execute a row, you're going to check the salaries to see if one is greater than the other. If yes, you will update it and set it to whatever that second table was from. Otherwise, it would just skip.
You are almost right, but look at this. What is stated there is for each row. T1 is the old value of this row, and T2 is the T2 is the new value of this particular row. Given that, can you rephrase?
Yes. So for Charlotte, you're making sure that the salary is always going up and never decreasing.
On the opposite, he is doing the opposite. Yes, please.
Oh.
Yes, I have a question. It's called non-decreasing salary, but why do we check if the new salary is great when
Maybe the name is not correct. So this is a typo error. So if I would explain this to Charlotte, how would I say?
Whenever the salary decreases, whenever the new salary is greater than the old one, which means that it increases, someone gets a raise, you would set the salary to be the same as the old one.
So if I say to Charlotte, I forbid any increase of salary in my company, is that okay for you?
Yes. This is the code for it.
Yeah, okay, so this is the idea. So this is the kind of trigger that the kind of language we use for triggers. So again, the syntax very fast, create trigger name. You please, as you mentioned, we need to have a right name for the triggers. We will have hundreds of these triggers. I missed, my name was not wrong, was not okay, was wrong. Either before or after one of these events, insert, delete, update, or update of a particular column. A trigger is always associated to a single table name. Here it was employee table, referencing it just an alias for the old and new values of the row. There is no such a thing for tables, so they are not T1 or T2 or inserted or deleted. This is the problem. You have only these two alias for the single line, but you don't have the equivalent for the statement level. So you have an alias for the previous value and new values of this row. Instead of having a statement level, all the old values that change it, the new value that change it.
So this is similar to our inserted that we were using on a statement level, but just at a row level.
At the row level. Yeah. But there is no inserted and deleted at the statement level.
Yes. Yeah.
And that's all. And then action PLSQL block, you put whatever you want SQL code into that. Yes, this is an interesting example. Just to understand how this thing at the same time all the referential integrity should, how does a trigger like your trigger here, this trigger that we will see, react with respect to referential integrity? Okay, so now this is the objective to explain in this example. We have a table like this for the inventories. We have 200 units of the first article. When this number of units, part on hand, goes below the reorder point, we need to order 100 units. And ask our provider to send us 100 units. Okay, for this, for the first, the same for the second, and the same for the third. Suppose now that we have this trigger, reorder, after update of part on hand. Okay, so when I sold some units, part on hand, part on hand is the thing you are available when you are on Amazon website. You ask 200 units, there are no more units anymore. Okay, and then immediately when you pay your order, the number of units will be immediately updated here. So let's see what this trigger does. After update of part on hand on inventory for each row, is the new part on hand is less than the reorder point, then we do this. This is PL SQL code is SQL with variables, if then else and loops. We declare an. Can you explain me what this thing does? I mean, it's SQL with some variable management. Remember that you have one line in your hand, two lines. In your left hand, the old values of the row. In the right hand, the new values of this row. This is all you have. And this is called new dot something or old dot something. Okay? So this is what you have on hand. And one question, pending orders is before or after the update of this row? After. So you have this execution when you are doing this query, select pending order, you are accessing the table after the update has been done. Anyone has a guess? Yes?
Good try. If the part on hand is lower than the reorder points that you set, and that you don't have any pending orders, you put the quantity, the new reorder quantity into the pending orders. So you make sure you still have inventory.
So why these pending orders, the intuition, why these pending orders is there?
To make sure that you always have something in stock. That you can order something if you run out of it?
Because, well, from what I think, your last chunk of script said that you just generally want to have some stock on hand, but you have the possibility that a customer orders more than your usual stock. And so this is checking to see, is this new order going to be able to be fulfilled by your usual supply chain, or do you need a change to your usual ordering pattern?
That's the idea, but that's another issue. I don't think that this issue is ever considered into this trigger. The idea is as follows. Suppose that this is the first idea, the transaction, update the inventory, set part. Basically, the first update there is someone bought 70 units of that in their order, okay, for the first update. Then we put this trigger into place. Suppose that pending order is empty. Then what will be the result of this query? 0, because the pending orders is empty. Therefore, there is no pending orders concerning this new part number 1. And if this is the case, then we put for the part 1, we will put 150 units today. What happened? The idea is that next time that an user wants to have the part an issue of the part 1, I don't have to order again 200 units. So I need to order only once the 150 units, even if there are many orders that follow concerning the same part 1. Okay with this idea? So I don't need to add this 100 and the date of today every time I sell something when after the first time that I went below the reorder point. Okay? So I do not want to repeat the same insert in the second bullet as many times. So I order once, even if I continue using my stock until 0. But I order only once 150, okay for that? So in the same day, I have another 60 units. I said for all the parts bigger, for all the parts bigger than 1. Again, I go here. Now pending order has something. then 1 is different than 0, I do not insert again a new tuple. That I do this for the first part, for the second part. For the second part, I have minus 60, which is below 500, it's okay. But for the third part, I go beyond the reorder point for the first time. I order a new, I do a new pending order. Okay, for that. So for maybe you, when you say that all this works nicely, you will say you are really not fair with respect to Oracle. Yes, in this little example that works. As soon as they have the example of the employee that does not have, cannot have a salary bigger than the manager, a little bit more complexity, and this model breaks. Of course, we need to understand how, even if at the syntax, something similar can be written in PostgreSQL definitely, but also in SQL Server. So we have 3 triggers that more or less, it's a variant of this dialect. The 3 triggers will perform completely different in the 3 platforms. Why? Because the algorithm that is used to order the trigger execution is different. You remember that the order execution that we discussed last time in Starboard was as follows. We have in this example, suppose that we have T1 and T2 that was launched. Here again T1 and now T3, here T4. We collect all these triggers somewhere in a list. Then is this set of triggers to be processed empty? No. Then we took among all these the one that has the highest priority. We executed. No, we evaluate the condition. If the condition is true, we remove it from the set of things to be processed. We process this last trigger. Could launch other triggers. And then we put the T5 and T6, which are just launched by T4, in the same pool as the others. And we loop until everything is empty. Okay, this is one algorithm, one possible algorithm for executing a chain of triggers. That each of these triggers can itself launch other triggers. Okay, with this algorithm. Now let's see a completely different algorithm for a similar syntax. Here. How does this work? Here we execute first the statement level before triggers. Then for each row, so there are triggers before, at the statement level we execute it, and then we perform all the necessary modifications. Then we execute the row level before, so now we are at this line. We execute the row level before trigger for this line. We execute the update and then check the row level constant, etc. Then we execute the row level after triggers. And then continue accumulating and then go to the next step. And as you can imagine, in the simple example that we saw, the first 2 examples that we saw in this course, the 2 triggers, if we inverted one executed before the other, the output of the database at the final state will be different, okay? Here is the same, depending on the order on which things you are doing, the outcome of the database will be different. Even if syntactically you can explicitly run this query or almost this kind of query in PostgreSQL or SQL Server. It is important that you understand which algorithm is used for launching a chain of triggers. Yes?
One question. If the execution mode is not deferred, it's immediate, isn't there a problem with, for example, infinite recursions?
Yes, this is the case, but this is the case independent of the whether it is deferred or immediate. The problem it is on your responsibility. As we discussed in the first lecture, it is difficult to have a cycle forever with a small program in C or in whatever language. But with 3 lines, you have a loop forever in triggers. So you need to be much more careful when you program.
Okay, because one thing that I still didn't quite understand is active databases seem like a really powerful tool, but there's no easy way for us to manage the complexity that triggers can have, right? In that sense, how does this scale? For example, if I have a requirement sheet that has 5 requirements, it's easy to make it with triggers. If it has like 1,000, managing the interactions between them, is that manageable on a large scale?
Yeah, this is exactly the problem. Why? Maybe you are saying this is advanced database course, and you are saying, but this is Oracle and traditional technology. Yes and no. You have the same problem into these complex event processing systems, which is a well-established technology based on the same idea. And you have the same problem. A complex event processing systems is reacting to events and can produce new events, and you need to manage all these events. The problem is that we don't have a software engineering tool that help us to debug, to understand. So if you are debugging in C or C#, you have a lot of tools, Visual, C Lion or Visual Studio, that helps you to find the problem. Here you are alone, and therefore it is a very powerful tool. What is the idea? And I will show an example at the last slide of this chapter. For me, after many years of teaching and practicing this technology, it's like distributed processing. You need to have we already mentioned this last time. How to make sure that a distributed algorithm performed in different nodes will surely end up doing what you want. This is complex. Have you ever took any course in distributed? So this is the same problem. Do we have, when I was studying, this topic was not existing, so I have when I studied, so I don't have a proper education on that. Did you ever have the right tool for analyzing this?
Not that I'm aware.
So how do? You need to think. So this is the problem for distributed computing or distributed processing or distributed algorithm in general. It is complex. We don't have support for that, and this is a particular example of distributed computing, because my way to solve this problem is to think in a ostrich kind of philosophy. You put your head on the sand and you concentrate on the single thing you are doing. And you are doing this in the best possible way. Are you sure that when you ask to do something, I did it and then I forget the rest? So you need to first be sure that every individual trigger is working perfectly. And typically how it is debugged in the real application, you deactivate all the triggers. And then you concentrate on your single trigger. And then verify with all possible test cases that it covers all exceptional and corner cases. Then you put the second, or you know that for a single integrity constant you have 3, or if this integrity constant involves 3 or 4 tables, you will need 2 or 3 triggers for each of these 4 tables. So you concentrate on these 4 or 5 triggers for ensuring this constant that an employee cannot have a salary bigger than his manager. Then you deactivate every other possible triggers and do sufficient tests on all the possible combinations. If you add this or remove that, if you reduce the salary, if you increase the salary at the upper level, at the medium level, at the bottom level. So you do all the possible test cases. When I'm sure that these 2 or 3 or 5 top triggers work for your application, you hope that the other guys are doing the same thing in the right order and pray that everything works well. So alas, there is no morality. No one is using in real application. You even have an assistant that was enthusiastic teaching and doing the lab session for this course. He went working onto a bank. He almost get fired because he proposed to use triggers instead of standard C code for doing all these kinds of things. So it is in companies. It is suppose that this is too dangerous, and then you cannot allow to do triggering to your applications.
That's a pretty big statement. So where do we do triggers? If not in companies, who's doing triggers if they're so dangerous?
You need to see, depends on the company, depends how dictator is your CTO. If your CTO is dictator and say no triggers, then no triggers. But this is a very useful and very powerful tool to do very nice things with very simple code and with enough disciplines. You can you can perform, put hundreds of thousands of triggers, because basically each trigger tackles one column, salary and manager. So you manage these two columns, the trigger with these two columns, and the others will do other columns. Whether you have that amount of children and you live in this neighborhood, then you have an additional bonus or something. But that will be the trigger that only focus on that. And then they do not modify the salary. So with a little rigor, you can easily manage to think amazing thing with few triggers. So we are doing this for every we do it for every line. We do the before, execute the before triggers. We do the update. We execute the row level after triggers. We cycle. At the end, we perform the stated level constraint and assertion checking. So this is the thing that you do when you say referential integrity. Referential integrity goes at this place. And then after referential integrity, you do your own statement level after triggers. Okay for that? So this is an idea of the syntax. Yes, instead of triggers, it is also available in SQL Server. What could be instead of triggers? Say it again.
Procedures.
Not really. So you see that here we have before and after. And what would be instead of? For what? So instead of doing an insert, basically instead of doing an insert and delete update, do this piece of code that follows. Why should we need this instead of triggers?
Couldn't you just do like a rollback and an after?
Yes, it's something like this, yes.
In case doing the operation is already forbidden, for example, if you want to delete something, we want to delete a row, but there is a foreign key constraint that avoids it.
You are in good intuition. I will go a little bit longer in this intuition. Typically, for many reasons, there are many reasons for using instead of triggers. You have an employee table with 50 columns, including very confidential information. Okay? This confidential information about the employees, it's only accessible for the head of human resources. Not even the director has access to that. So typically you hide these very confidential columns and you put that into a view. The view does not exist. The view is just something to protect the access to this confidential information, and you give to your users access to this view. The user suppose that he's working on a real table and says, I hired a new employee, and then he wants to use this public information to the hiring. But this table, this view does not exist. It's simply a view. Therefore, we need to replace this with a real update on the real table and eventually put the null values here or get this information from other tables. So we are replacing the operation that the user is supposed to do on a real table that is stored into the database. Okay, with this idea of, this is one use case, yes?
Just one question in that scenario, because that's really interesting. Do you create the trigger? I mean, when you create a trigger, you specify on which table it will operate, right? So in that scenario, you would specify it on the view. Can you do that?
I would immediately say that the yes and no. Typically, instead of triggers are done internally. When you do create view in Oracle, and then you access update rights to this view, Oracle or SQL Server immediately creates a full bunch of instead of triggers that are internal to the system. So when you say update this table, you don't know whether you are manipulating a table or a view. You never know. Only the sysadmin knows. Only the database administration knows. Therefore, you manage as if it was a table, and then Oracle or SQL Server transform your insert, update, or delete with these triggers into the real tables on the hard disk. And by the way, we will see in a couple of slides that every referential integrity that you put into your tables, employee, manager here references employee SSN in the same table. These are just creating internal triggers by the database system. So trigger is the assembly language that is internally used by the system to perform tasks. Okay, we will see examples of this idea. So instead of example of trigger, for suppose that you have a table manager, which is a view or even a materialized view. You know the difference between a view and materialized view? Do you know what is a view? No. So we have in SQL something which is called create view, and then you give a name as, and you put a SQL query that can have 100 lines of code. This SQL query will give us result, a table. And therefore you manipulate this view n, and you use it as it was a normal table, insert, update, etc. How does this work inside? Query rewriting. It's text manipulation, basically. Query rewriting, when you have select something from, you put n and other table where, what SQL Server does, it just replaces the name of the view with the SQL code inside the query to have a single query that addresses not the view but the base table. The problem also, the complexity is that this view can use another, suppose that this is v1. Here inside this query we have another view v2, which is also defined by a create view v2. And then recursively, you can have as many views embedded one into the other. So the problem is complex because you need to take into account all the possible view definitions that can be in a chain. But at the end, it is the simple rewriting process. When you use a view here, you replace it by this definition and you execute a single query. Okay, for that? Why do we need views? We have already seen that in this example of the protection for sensitive information. But basically we have the physical tables here. So we talked this morning about the physical level. We have, so these are on the hard disk. On the other hand, we have a collective views, which are at the logical level. We have a bunch of tables here at the logical level, and at the user level or external level, we have another kind of views that are based on that. So here is the view for the director, this is the view for the financial department, this is the view for the human resource department. So we have the real tables are here on the hard disk. These can be distributed. You already touched distributed tables in the other course, database system architectures. But basically, at this level, you can suppose you have a single database on a single machine. And at the physical level, basically you are putting on Azure, and then you have hundreds of nodes doing splitting the data in these hundreds of nodes. So this is a physical implementation of a single database, okay? For that, at this level of abstraction, you manage only one single database. But here, you need to take into account Azure and all cloud and whether load balancing, etc., etc. So you separate concerns. But at this level, the rector does not have access at ULB. They are, I don't know, 10,000 tables. Each table has 50 or 100 columns. There are 1 million columns there in the database of the ULB. It's a very small database in nowadays. The rector is not able to understand all these million columns. So the rector, we provide a view that is fit to his way of thinking of his academic aspects. So we have a view here. A query on this view will be translated into this community schema. The view, for example, here can access only this table and this table because these are only the academic part, the two academic part of the database that this rector needs here. Okay? So with this view mechanism, all this is query rewriting. And then you can have a very complex query here that result into this chain of view definition. This query can take very much time. And if the rector asks the same question many times and he has to wait 5 minutes to the answer, he immediately will ask the sysadmin of the database of the ULB. Then what is his, the rector cannot wait 5 minutes. What can we do? We have this schema here. Someone has an idea how we can solve this problem?
Pre-process and update according to needs.
And this is called, in more technical terms, materialized views. And now you understand what is materialized views. Instead of having a views here, because it is transformed in query, in a complex query processing state here, query transformation, and then another query transformation to put it on the right nodes on the cluster, I already pre-compute and store. So I already store the view. Suppose that you have tables like this. I have 2 or 3 tables like this. And out of these 2 tables, I compute a view. What is the problem? What I gain and what I lose when I materialize a view? Yes?
First, you need like this space.
This space is free, but it should be taken into account today. Not free, but almost free.
The other thing that you lose is that it doesn't update automatically. You have to update it manually, I believe.
And manually, it's reasonable to depend on someone for this update. Triggers. Thank you for this answer.
And the thing that you win is performance because it is
Performance in which operation?
in querying, like reading.
In reading, but you lose when writing, because since these are the two base tables that are already there, each time there is a new line here or a new line here, I need to update the materialized view. Okay? And therefore, depending, it's the traditional 80-20%. If 80% of the time I access this view in read-only, I gain. And then for the other 20% of the rector has to access this view in modification, he needs to pay the price. But at least 80% of his operation will be faster. Okay for that?
So is there a difference between, or what is the difference between a materialized view and a data cube?
Exactly, materialized views exactly are the data cubes.
It is, okay.
I mean, they are one way of implementing is the data cubes is with materialized views.
Okay, so data cube is the general
The
term.
white cells that we saw in the morning are the base facts, and all the color cells are already stored in a materialized view.
Thank you.
So instead of putting create view in SQL, you put here creates materialized view, and then you have, this is the command, but let me see, restrictions, Oracle. Oracle materialized view, where I can find the restrictions. Create materialized views. I don't know whether I found the right restrictions here in this page, but basically semantics, no, then update, let me see, Oracle, update. I don't know where I find it immediately. Maybe I will, for the next time, I will put here. So basically the idea is that there are many restrictions. Restriction, if I look restrictions, yes, maybe here. So every consideration, every database system had a lot of restriction in order to say if you have an update on this materialized view, you cannot use union, you cannot use count, you cannot use, so you have a lot of restriction of the things you can put here in the SQL query to allow a materialized view to be updatable. Because basically sooner or later, for all these materialized views, a trigger will be issued by Oracle. And as soon as it is too complex for them to generate this internal trigger, they say, no, it is your responsibility. What happened then? It is yourself that you need to write the trigger, think, and write the trigger to make this updatable, to materialized view updatable, because you limit the trigger, the capability of Oracle to update. But you know, because you know, understand your application domain, you know that you can, nevertheless, it is possible. Basically, what the problem here is that you need to, in every possible circumstances, make sure that whatever update in the base table can be reflected and translated into the code of your trigger to put an update into the materialized view. So there should be a univoc equivalent between an update on the materialized, on the base tables, and the equivalent to the materialized view. There should be a single way to perform it. As soon as you have a union, of course, this is problematic, because if the union is if the user makes an update here, and the materialized view is a union of two tables, where I should put this table, this new tuple, here or here? Maybe the Oracle does not know, but you immediately know if the, I don't know, if the identifier of this person, if or if this is a student, it goes in this table. If this personnel, it goes in this table, and you have additional information from the domain that you can replace a single update on the view to transform it in a precise update of the base tables. You get the idea of the union. The union is ambiguous unless you have a specific application information that you can differentiate when you have an update here to which of the two tables it will end up. Question?
Is the materialized views like something that's ANSI standard?
Yes.
Or, so you can find them in SQL Server in the okay.
But every one has limitations in the number when it can be updated and when these updates are all maintained automatically by the system. And you compare the two, you will see that one of them, I mean, it's also a competition. Every new version, they add a new clause they take into account one additional case. So you get the idea of materialized view. So this is the idea of instead of triggers. They are used internally, in particular through materialized views. Let me see what time is it, and then yes, maybe we can have the 5 to 10 minutes break to start with TB2.
The right one.